Hello everyone. Today we'll be having NPTEL Live Session 10. So let us wait for a few minutes so that everybody joins and then we'll start. Okay. So let us start today's lecture about data link layer. So till now we have studied various OSI layers such as the application layer, presentation layer, session layer. Then we have talked about the transportation layer and then the network layer. data link. Now comes the next part about the data link layer and the physical layer. So in this lecture, we will be discussing about the data link layer. So as we see that what is the functionality broader of data link layer? It helps to transfer of unit of information, then it helps of framing of packets, and then do the error checking of the packets. Whether that packet contains some error or whether the transmission is done properly, so any packet gets lost, etc. That is again done by the transport layer we have studied. However, this is at the node to node, or in the transport layer, we have to implement hop to hop. However, in data link layer, we have to check for node to node. Like in a network, if we want to send the packet from one node to another, so in a network, when we want to send the transfer the packets from one node to another, at that time we take the consideration of a data link layer. It helps to the transfer of unit of information. It helps to framing of the packets, and then it also helps for error checking. So as we have seen, this is the OSI or TCP/IP protocol stacks and the protocols which are underlying over these layers. So for the case of data link layer and the physical layer, the protocol which is implemented is known as Ethernet. So we'll be broadly discussing what is Ethernet and what are the layers in between in between that protocol, and how are they performing their functionalities. So those kind of thing we'll discuss, and then we'll discuss about the flow control and the error control in the data link layer, which is very much similar to the transport layer. However, we will again discuss if anybody is having any uh, queries related to that. So we have studied above the data link layer is the network layer, and below the data link layer is the physical layer. So the data link layer composes of two different layers. One is the medium access control layer, that is the MAC layer, and second one is the logical link control layer, that is LLC layer. So this logical link layer helps to communicate between the network layer and the data link layer, and the medium access control layer helps to communicate between the physical layer and the MAC layer. Okay, as you can see here. So we have two distinctions. One is the logical link control sublayer, and another one is the medium access sublayer. So this logical links control sublayer makes the connection between the network layer and the data link layer, and the medium access sublayer helps to make a connect between the physical layer and the data link layer. So what is the issue between, for example, there are two hosts which wants to connect to each other. So we usually connect them using a wire. So it is sharing a wire, but however, what is the issue of sharing a wire? That what if there are more than one host, more than two hosts, so that may be a mesh of the wires and wires for everybody, that is very difficult to handle. So that is why how to share, there is a way to share the wire, and that is implemented using the bus topology. So in data link layer, the wiring technique, or wire is a kind of logical wire. It is not the hard wire that we are saying or the physical wire. We are just talking about the logical interpretation of wires. So if we want to share a wire, we are implementing a bus topology. Like this is the bus, and all the hosts are connected over the bus, same similar bus. So this kind of bus is used in case of data link layer for the communication purpose. So second thing is that there are multiple hosts connected to each other and wants to communicate with each other. So the thing which should be kept in mind, issue two, is that listen before you speak. So if all the hosts try to speak at the similar time, nobody will be able to listen to each other. So that is also a consideration or issue that we need to keep in mind. That means simultaneously speaking, as we discussed right now. Multiple hosts are speaking, however, they are not able to hear each other. So in our, this is a case of daily example, like we talk, like three people are sitting and they are trying to communicate with each other. However, if two people start talking at the same time, and then the third one will not be able to interpret what the other two are talking, and even those both will not be able to hear about each other. So the third issue is the recipient of packet. So we need to put an address on the packet, that which packet is received by which host, and the format of the packet needs to be defined. Then how do we know what is the address you want to send to and to which host? So for that purpose, we have the protocol of Ethernet, and it is IEEE 802 standard. So data link layer and physical layer collectively form or implement the protocol known as Ethernet. So you have seen here data link layer is bifurcated into two parts. One is the logical link control layer, and one is the medium access control sublayer. So broadly, the protocol implemented is Ethernet, and for thereby further the protocols which are used to implement these MAC layer along with the physical layer are IEEE 802.3, that is CSMA-CD, then token bus protocol 802.4 and 802.5, that is token ring protocol. So this is the scope of the discussion which we have. This is the medium, and we have the physical layer above which there is a data link layer, which is bifurcated into two parts: logical link control and medium access control. And then this logical link control has the service access point, which tries to communicate with the upper layer protocol. That means all the headers which are coming from the network layer or the transport layer are framed in case of the logical link control layer. And apart from that, all the other IEEE standard protocols are implemented in logical link controller and the medium access controller along with the physical layer. So now we will dig in deeply to the functionalities of each of these layers. So if we first consider the physical layer, it helps in the case of encoding or decoding of the data. So this is the case, like we cannot directly transfer the data from one host to another in the similar manner as it is present in case of one host, because that might be attacked by various breachers. So for that, there needs to be some encoding and decoding mechanism, which is implemented at the physical layer. Then there is the preamble generation or removal. Then the physical layer implements the bit transmission or reception. That means it helps to transfer one bit at a time or multiple bits at a time, and tries to receive the bits accordingly. And that protocol is implemented by the physical layer. And it is also a transmission medium and a topology. Then what is the function of logical link control? It is the interface to the higher levels, as we have already talked about, and it helps in case of implementing flow and error control between the data transfer between one node to another inside a network. Then what is the functionality of medium access control? So it is a data assembly and dismantle into frames. It does the data assembly and then it creates the frames out of those data which is assembled. Then it governs access to the LAN transmission medium, that is the physical medium. It tries to connect to the physical medium. So this is the scope of the LAN protocols. So two stations or a system that communicate via a shared medium is known as a LAN, logical area network. Then higher layers above LLC provide end-to-end service between these stations. Like this is the one station, this is the another station. And they provide end-to-end connectivity directly. Then below the logical layer, the MAC layer provides the necessary logic for gaining access to the network. So this MAC layer tries to gain the necessary access to the network by say we have the ARP protocol, which finds out the address to the corresponding IP address, that is a MAC address to the corresponding IP address. Then it connects over physical medium. So all those communication are done using MAC and physical layer. So LLC layer for LANs is concerned with the transmission of a link level protocol data unit, that is PDU, between two stations without the necessity of an intermediate switching node. So this is containing a protocol data unit. What is protocol data unit? That is the data along with the headers, which is coming from the layers above the logical link control, that is the network layer. So the two characteristics it possesses is that it must support the multi-access shared medium nature of link, and it is relieved from some details of link access by the MAC layer. So now we talk about the LLC layer, services. That is the services, it provides three type of different services. One is the an acknowledged connectionless service. That means it is a datagram style where the data is transferred from one station to another. However, it is not even acknowledged. So we do not know whether there is it does not involve any kind of flow or error control mechanism, and data transfer or data delivery is not at all guaranteed. Then we have the connection mode service, which is a logical connection is set up between the two stations, and then flow and error control is implemented. Then we have the acknowledged connectionless service, where a cross between the previous services, it is a cross between the previous services, and here the datagrams are to be acknowledged. So no prior logical connection is set up, no connection establishment is done. However, data is being transferred and is acknowledged by the receiver end. I hope everyone is clear till now. Yeah, Akshit, you have any doubt? Yeah, you can ask.
Good afternoon, ma'am.
Yes.
Ma'am, what is the difference between acknowledge and unacknowledgement services?
So acknowledgement and unacknowledgement means that in an unacknowledgement service, when we send the data from one node to another, if it is received by the node 2, so the node 2 does not give any acknowledgement status to the node 1. However, in acknowledged service, the node 1 sends data to node 2, and the node 2 sends an acknowledgement tag to node 1 back. So that means the node 1 is aware that the data is being delivered.
Okay,
Okay.
ma'am.
Okay. So now we will talk about the medium access control layer, which is the MAC sublayer, and it is primarily used in broadcast or shared channel networks. So MAC protocols enables two stations or two nodes using a shared communication resource to establish, maintain, and terminate a connection. So its examples are satellite, Ethernet, or cellular network. Then the MAC helps in assembly of data into frames with the address and error detection fields. So this assembly of frame and performing of address recognition and error detection is again performed by the MAC layer. So it governs access to transmission medium. For the same link logical control layer, several MAC options may be available. So all LANs consist of a collection of devices that must share the network's transmission capacity. The function of MAC protocol is that some means of controlling access to the transmission medium is needed for efficient use of that capacity. So the key parameters in any MAC technique is where and how to send. Where refers to whether the control info is exercised in a centralized or distributed fashion. That means what is the difference? We will discuss about the centralized and distribution. So in centralized, a controller has the authority to grant access to the network. However, in distributed, the stations collectively perform a MAC function to determine dynamically the orders in which stations transmit. Next question is how. How is constrained by the topology and is a trade-off among competing factors such as cost, performance, and complexity. Okay, so let me first take a halt here, and I will first discuss the previous assignment, and then we will further proceed. Okay, so what is the purpose of a routing table in IP routing? So all of you should give an answer in the chat box. Yeah, so the correct answer is C. That means routing table in an IP that is used to store information about the best path to reach the destination networks. So the routing table is used to store information about the available network paths, including destination network address, next hop routers, or outgoing interfaces and its associated metrics. It enables routers to make forwarding decisions based on the best available routers. So what is the role of forwarding plane in an SDN network? So why not B? That means B, its routing table is help. It is having multiple fields. So it does not only stores the IP address. IP address of the destination is being attached as a header. However, the routing table helps to find out the best possible route between one node to another. That is the purpose of routing table. Yeah, so we are on to the second question. So here, what is the role of forwarding plane in a STN architecture? So the correct answer is D. So the role of SDN architecture is to forward data packets based on the instructions from the control plane. Uh, it does not, Akshit, it does not control the flow of the data packets. It helps to forward the data packets. What is the primary benefit of using SDN in a network? What do you mean by forwarding plane is same as data plane? What is the forwarding plane? SDN has two planes. What one is the control plane and another one is the data plane. The control plane acts as a brain and it provides all the routing information, and the data plane helps to just forward the network, forward the data packets. So the definition of flow in the network is very different from forwarding. You know that, I hope. So the answer to question number 3 is C, that is right, simplified network management and automation. The primary benefit of SDN is simplified network management and automation achieved through centralized control and abstraction of network infrastructure, leading to improved efficiency and reduced operational cost. So which SDN protocol is used to communicate between SDN controller and network devices to program forwarding behavior? The correct answer is B, that is OpenFlow is the SDN protocol used to communicate between the SDN controller and network devices, enabling the controller to program the forwarding behavior of switches and router. So the next question is, what is the purpose of a default route in a routing table? The correct answer is B, to provide the route for packets and unknown destination addresses. How does SDN differ from traditional network in terms of network configuration and management? Okay, so the correct answer is A. The SDN uses centralized control and programmability, while traditional networking uses distributed control and manual configuration. Which routing algorithm is commonly used in SDN to compute optimal paths for data packets? So the algorithm which is common use is Dijkstra algorithm for data packets based on the shortest path algorithm, considering link cost and network topologies. How does SDN facilitate network virtualization? So the correct answer is C. That means SDN facilitate network virtualization by creating virtual networks that can be configured and managed independently from the physical network, allowing for greater flexibility and efficiency in network operations. What role does the southbound API plays in SDN architecture? Yes. So the correct answer is A, that is the southbound API. acts as a vital communication channel between the SDN controller and network devices, playing a critical role in enabling the centralized control and programmability that define the SDN paradigm. And the northbound API plays a role between the communication between the application and the SDN controller. Okay. So the last question in this assignment is that how does SDN improve network scalability compared to traditional networking? Mm, 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 mm. So the correct answer here is A, that is SDN improves the network stability by dynamically allocating resources based on the demand and ensuring efficient use of resources without manual intervention. Okay, so we end this assignment and then now we will discuss about the remaining part of the lecture. Question number 7. What doubt do you have? Yeah, so I mentioned that in SDN we use the to compute the optimal paths for data packets based on the shortest path. So the shortest path algorithm used is Dijkstra's algorithm. No, all are not the shortest path. They are different algorithm. Like Floyd-Warshall is something else. Like the shortest path only, but it uses the more complexity. So based on the shortest path algorithm, we it is producing the shortest lowest link cost, and the network topology also is easier in case of Dijkstra's algorithm. Okay, so we were discussing about this LAN protocol. So we have this application layer data at the application layer. Then the TCP header is added after the application layer data. Then forwarding the IP header is added at the network layer or the IP layer. Then we add the LLC header at the data link layer of the LLC layer. Then we add the MAC header and MAC trailer at the MAC layer. And this is the kind of total MAC frame prepared. So the generic MAC frame format is as follows. We have the MAC control, which contains control info for the functioning of MAC protocol. Example, it is a priority level queue or round robin queue, etc. Then the destination MAC address, which the destination physical attachment point on the LAN for this frame. Then the source MAC address, that is the source physical attachment point on the LAN. for a particular frame. Then the LLC PDU, that is the LLC data from the next higher layer. And then the CRC, that is cyclic redundancy check field, which used to check if a transmission error has occurred or not. So the MAC techniques can be synchronous and asynchronous. So synchronous is the one with a capacity where a capacity is dedicated to a particular connection. The same approach as in the circuit switching FTM or TDM, so not optimal for LANs. I mean, if the same capacity is given, however, some of the nodes need less capacity, however, the other nodes connectivity need more capacity. So this is very unpredictable, and it is not optimal for LAN or MANs because the need for the stations are very unpredictable. Then we have the asynchronous type of techniques where the capacity is allocated in a dynamic fashion in response to the demand. So it is subdivided into three categories, that is round robin, reservation, or contention. So in round robin, as you know, we have given a certain time quanta, and based on the time quanta, each capacity is allocated to a particular resource. Then we have the reservation, that a particular time duration is reserved for this source of stations. Then there is contention, which has the similar objective. Then the method used for MAC are, that is medium access control, are carrier sense multiple access with collision detection, that is CSMA CD, and for bus topologies, or the control token or token passing for bus and ring topologies. So now we will see how CSMA-CD works. So CSMA-CD is used only in bus type of networks where a number of nodes share a common communication channel, that is wire, which is known as the bus that we have talked about. This is a kind of bus we have. We have one node, we have another node, like we have multiple nodes with us. And if they all want to communicate with each other, then they are all connected using this bus. So this is the bus architecture that we have seen. Sorry, my cursor is not good here. Then in CSMA CD, there are different things implemented. First is the carrier sense. So it sends whether the carrier is available or not. Then if there are multiple access to that carrier, like A and D wants to access that carrier at the same point, then there occurs a part of collision. Here we see this is a collision domain. Here A and D wants to access the channel at the same time. So that point of time, we need to detect the collision and use the back-off algorithm and jam the signal that the carrier should be jammed and no other system should be able to use it. So this is the basic operation of CSMA CD. To transmit data, the source station assembles a packet comprising of the destination address, the data, and the control info, as we have all seen. The source station listens to the cable to determine if the bus is currently in use or not. So it sends the channel. So if so, it waits until the bus is free. Else, it transmits the packet. So this operation is known as carrier sensing. So during transmission, the source station continues to listen to the cable to detect if another station has also initiated a transmission or thus causing a collision. So this process is known as collision detection. Say if source A has already started sending a packet, it will keep on sensing. So like it will again sense the whole network that whether that there is some other uh, packet or other node which is transmitting over that same network. If that is the case, like here comes a D which is trying to access the channel. So at that time, the collision occurs, and this process of detecting the collision is known as the collision detection process. So if a collision is detected, then to ensure all stations are aware of the collision, the source station transmits a random bit pattern known as the jam sequence. So stations involved in the collision then back off for a random period of time before retrying for packet transmission. This is how CSMA-CD works and prevents the collision. So, what will be the maximum collision time? How long does it take to realize that there had been a collision? The worst case is that two times the end of propagation delay. Say the has started the propagation and the packet has been reaching here. It sends the this it it is also sensing again the network. So a packet has reached here. It starts sensing, and when it has sensed, the packet has reached till this point at the almost end of the network, and the sensed part reaches back to the the sensed message. That means twice the end-to-end propagation delay takes for detecting the collision has been occurred. So another way of controlling access to a shared transmission medium is by a control token, that is token passing. That is another way, and it can be used both for bus and ring network topologies. So the control token technique uses a control or permission token to share the communication resource between a number of or set of nodes. This technique can be applied to both bus and ring topologies. So this token is passed from one station to another according to the defined set of rules. Say A has the token, then it has send a packet, and then it needs the token no more, so it gives the token to D now. Now D has the token, it sends the transmission and completes the transmission and sends the token then to B. So then B sends the token to C. So this is how the token passing takes place, and this can be implemented in a ring topology or a bus topology as well. So a station may transmit a frame only when it has possession of the token, and after it has transmitted the frame, it passes the token on to allow another station to access the transmission media. So this is how token passing networks takes place. A token always circulates around as a ring network. A user grabs a token to transmit the data whenever it needs to. So now we will discuss the last part, that is the flow control or the error control. So this is the similar kind of flow control which we have already seen in case of the transport layer. So flow control coordinates the amount of data that can be sent before receiving acknowledgement. Flow control is a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement from the receiver. Receiver has a limited speed at which it can process the incoming packet and a limited amount of memory in which it can store the incoming data. So the receiver must inform the sender before the limits are reached and request the transmitter to send fewer frames to stop temporarily. Since the rate of processing is often slower than the rate of transmission, the receiver has a block of memory that is buffered for storing incoming data until they are processed. This is the flow control, and then there comes the error control, which includes both error detection and error correction. So it allows the receiver to inform the sender if a frame is lost or damaged during the transmission and coordinates the retransmission of those frames by the sender. Error control in the data link layer is based on the automatic repeat request, that is ARQ. Whenever an error is detected, specified frames are retransmitted. So these are the three mechanisms that we use, that is stop and wait, go back and ARQ, and selective repeat ARQ. So as you know, stop and wait, only one bit is used. So either frame 0 is used to send or frame 1 is used to send. So sender keeps a copy of the last frame until it receives an acknowledgement. So here it keeps a copy of the frame that it has sent frame 0 until it receives the acknowledgement. For identification, both data frames and acknowledgement frames are numbered alternatively 0 and 1. So if frame 0 is been sent from sender to receiver, so the receiver receives frame 0 and sends the acknowledgement for the next frame, that is acknowledgement 1. It needs the next frame. Then the sender sends the frame 1 and receiver sends the acknowledgement of next frame, acknowledgement of 0, and so on. So sender has a control variable S that holds the number of recently sent frame 0 or 1. Receiver has a control variable R that holds the number of next frame expected, that is 0 or 1. Sender starts a timer when it sends a frame. If acknowledgement is not received within an allocated time period, the sender assumes that the frame was lost or damaged and resends it. The receiver sends only positive acknowledgement if the frame is intact. Acknowledgement number always defines the number of next expected frames. As we have seen, the acknowledgement will be 1 if frame 0 is received. Acknowledgement is 0 if frame 1 is received. So in law, if any packet gets lost or it is a when a receiver receives a damaged frame, it discards it and keeps its value of R. After the timer at the sender expires, another copy of frame 1 is sent. Here frame 1 is lost. However, the receiver was updated that it will be receiving frame 1. So again, the sender will send frame 1 after the timeout has been occurred to the receiver, and then the receiver acknowledged after the receiving of that frame 1. So if the sender receives a damaged acknowledgement, that means this acknowledgement is damaged, it discards it. When the timer of the sender expires, the sender retransmitted frame 1. It thinks that the frame 1 is not received. So it again transmits frame 1. So receiver has already received frame 1 and expecting frame 0. So therefore it discards the second copy of frame 1 and again sends the acknowledgement that it needs frame 0. This is how the lost acknowledgement and the lost frame is served in stop and wait ARQ. So in case of a delayed acknowledgement, acknowledgement can be delayed at the receiver. So it is received after the timer of the frame 0 has expired. Say this was the timeout. The acknowledgement has received after this timer is expired at this point. So the sender will feel that the frame has not reached. It again sends frame 0. So, however, R equals to 1 means receiver expects, here receiver is expecting frame 1. So the receiver discards the duplicate frame 0 and again sends the uh, acknowledgement. So at that time, the sender receives two acknowledgement for the similar frame, that is 1, and it discards the second acknowledgement and sends the frame. So for this purpose of confusion, sorry. We can also use a method of piggybacking, in which a method is to combine a data frame with the acknowledgement packet. So station A and B both have the data to send. So instead of sending separately, station A sends a data frame that includes an acknowledgement, that is frame 0 with acknowledgement of 0. And station B does the same thing, where this station sends frame 0. That means station A needs the frame 0 and station B sends frame 0 with the acknowledgement 1 that it needs the frame 1. So piggybacking saves the bandwidth if both of the station wants to send the data. What is the disadvantage of the stop and wait? In stop and wait, at any point in time, there is only one frame that is sent and waiting to be acknowledged. So this is not a good use of transmission medium. To improve efficiency, multiple frames should be in transition while waiting for acknowledgement. Two protocols are used to address the above concept. One is the go back in ARQ and the selective repeat ARQ. So in case of go back in ARQ, we send up W frames before worrying about the acknowledgement. We keep a copy of these frames until the acknowledgements are received. This procedure requires additional features to be added to stop and wait ARQ. Frames from a sender are numbered sequentially. So we need to set a limit since we need to include the sequence number of each frames in the header. If the header of the frame allows m bits of sequence number, so the sequence number range from 0 to 2 to the power m minus 1. For m equals to 3, the sequence numbers are 1, 2, 3, 4, 5, 6, 7. That means 0, 1, 2, 3, 4, 5, 6, 7. So we can repeat the sequence number. Sequence numbers are these, and again the repetition takes place. Again the repetition takes place. Here we implement the sender sliding window. At the sender sending site, to hold the outstanding frames until they are acknowledged, we are using the concept of a window. So the size of the window is at most 2 to the power m minus 1, where m is the number of bits for the sequence number. The size of the window can be variable. It can be at most 2 to the power m minus 1. The window slides to include new unsent frame when the correct acknowledgements are received. So here, before sliding, this was the window size that equals to 7. Then after these acknowledgements are received for 0 and 1, the window is slided from 2 to 0. So size of receiver window at the receiving side is always 1 in this protocol. Receiver is always looking for a specific frame to arrive in a specific order. So any frame arriving out of order is discarded and needs to be resent. Receiver window slides are shown in this figure. Receiver is waiting for frame 0 in part A, and in part B, receiver is waiting for frame 1. So sender has three variables, that is S, SF and SL. S holds the sequence number of the most recently sent frame. That means say here it 0. Then SF holds the sequence number of the first frame, that is first frame is 0, and SL holds the sequence number of the last frame, that is 2. The receiver only has one variable R that holds the sequence number of the frame it expects to receive. So the frame currently sent is 0, so receiver expects frame 0. So if the sequence number is same as the value of the R, the frame is accepted, otherwise rejected. So here, receiver sends positive acknowledgement if the frame arrives safe and in order. So if the frames are damaged or out of order, receiver is silent and discards all subsequent frames until it receives the one it is expecting. So the silence of the receiver caused the timer of the unacknowledged frame to expire, and the sender resend all the frames beginning with the one with the expired timer. For example, suppose the sender has sent frame 6 but the timer for frame 3 expires. So that means frame 3 has not been acknowledged. Then the sender go back and sends frame 3, 4, 5 and 6 again. This is called go back NRQ. The receiver does not have the acknowledge each frame received. It can send one cumulative acknowledgement for the several frames. So this is the normal operation of go back and ARQ, where sender keeps the track of outstanding frames and updates the variable and windows of the acknowledgements received. So here it is the sending 0, 1, 2, then received frame 0, then received frame 1, and acknowledgement has been sent collectively as 2, that frame 1, 0, 1 has been received. Then frame 2, 3, 0, that means 2 is sent, then acknowledgement for 3 is given, then frame 3 is sent, acknowledgement for 3 is given, and so on. So if a frame is lost for a sender, let's say frame 2 is lost, when the receiver receives frame 3, here it discards frame 3 and expects frame 2 a priori. So after the timer for frame 2 expires at the sender side, the sender resends the frame 2. That means go back to 2 and resend it, and then again frame 3 is resent. If an acknowledgement is damaged or lost, we can have two situations. So if the next acknowledgement arrives before the expiration of the timer, there is no need to retransmit all the frames because acknowledgements are cumulative in this protocol. So if acknowledgement 1, acknowledgement 2, and acknowledgement 3 are lost, acknowledgement 4 covers them if arrives before the timer expires. So if acknowledgement 4 arrives after timeout, the last frame and all the frames after that are resent. Receiver needs resends an acknowledgement. Receiver never resends an acknowledgement. A delayed acknowledgement also triggers resending of frames. So as we have seen, the size of the sender window must be less than 2 to the power m. That is, it sender, and the size of receiver window is always 1. So if m equals to 2, window size will be 2 to the power 2 minus 1, that is 3 at most. Then we have the selective repeat ARQ. Here we have said that go back and ARQ simplifies the process at the receiver side. Receiver only keeps track of only one variable and there is no need to buffer out of order frames. They are simply discarded. However, go back and protocol is inefficient for noisy link if it is bandwidth inefficient and slows down the transmission because it resends from the initial frame which was lost. However, in selective repeat ARQ, only the damaged frame is resent. Here, it is more bandwidth efficient and but more complex processing at the receiver is there. It defines a negative acknowledgement to report the sequence number of a damaged frame before the timer expires. So here are the sliding window at the sender end, and here is the sliding window at the receiver's end. So if frame 2 gets lost here, so it will send the negative acknowledgement for frame 2 and then the sender again resends the frame 2. The size of the sender window and the receiver window must be at most half of 2 to the power m. That means if m equals to 2, window size should be 2 to the power 2 divided by 2, that is 2. So window size is 3 and all acknowledgements are lost. Sender sends a duplicate of frame 0. Window of the receiver expects to receive frame 0. So accepts frame 0 as the first frame of the next cycle. So this is an error. So this was the overall things that we discussed about the data link clear, how the error control and the flow control takes place in the data link clear. Okay. If anyone has any doubts, you can ask now. Otherwise, we'll proceed to the assignment. Yeah, Akshit, what do you have and the doubts? Akshit, you have any doubt?
Yeah, ma'am.
Yes.
Ma'am, these protocols are inside the switch. Go back ARQ sliding window.
Yes, I mean these are implemented inside the layer 2 switch.
Okay. Now, how does this happen? By software? Oh,
These are the code bases and the kernel level implementations that we write, and these are the source codes that are present at the switches that does that implementation.
okay.
Okay, so I'll discuss this assignment at now. So MAC protocol enables two nodes using the separate communication resources to establish and maintain and terminate a connection. True or false? So sorry, you can see the answer here. So the answer is false. So it does not. MAC is concerned when the communication resources are shared between different nodes. So next question is, which is not one of the LLC services? Yeah, so the correct answer is intermediate switching service is not one of the LLC service. Which of the following are correct about asynchronous MAC techniques? Reservation method is suited for streaming voice traffic, or contention method is suitable for continuous traffic. Yeah, so the correct answer for this is A. That means only one is correct about asynchronous. That means reservation method is suited for streaming voice traffic. Contention method is not used for continuous traffic. It is for bursty traffic. Which of the following is true about CSMA CD? Sorry. So the correct answer is D, not A, that none of these are true. Like in a CSMA CD, that is the transmission, how the transmission occurs. So when a collision is detected, the source backs off. The source never backs off. Source sends a jamming message to the other nodes, and those nodes backs off for a fixed duration of time. And the worst case delay to detect a collision is equal to twice the end-to-end propagation delay, as we have discussed just now. So every station is connected to an Ethernet network, is provided by a 6-bit physical address by think about it bit. Yeah, so the correct answer is B. That means the network interface card. Every station connected is provided by 6-bit physical address by a network NIC card. So the T in 10 base T and 100 base T Ethernet technology stands for the answer is B, that is twisted pair. Which of the following is or are true? Mm. So the correct answer here is A and D. These are true. That in a fully duplex switched Ethernet, there is no need of CSMA CD method. And random back off in CSMA CD makes it less probable that sources would try to transmit in loop step after a collision is detected. So in go back and ARQ, if a sequence number is represented by 4 bits, the sender and the receiver window should be. So the answer is 15 and 1. So in go back in ARQ, the sender window size is 2 to the power m minus 1 at most, and the receiver window is always with the size of 1. When an acknowledgement is lost during go back and ARQ, the receiver retransmits the acknowledgement after a timeout. Is it true or false? The answer is false. So, according to IEEE 802.3, for collision detection, the maximum distance between hosts must be within. Yeah, Akshit, what do you have the query? What query do you have?
Isn't it true? Question 9.
No, it is not true. So in go back in ARQ, as I have just discussed this point, that the receiver never retransmits the acknowledgement after a timeout. So if the acknowledgement is not received, then the sender retransmits the packet. However, the receiver never retransmits the acknowledgement.
Okay.
Okay, so answer to this last question is C, that is 2500 meters. So I think it is clear. So that was all for today's lecture. If still you have any queries, so you can directly mail me or ask on the NPTEL portal. So this lecture will be sent on YouTube as well, so you can check over those as well. If you have any query, then ask. Otherwise, we can end the session.
Ma'am, exams are near, so can you share any tips?
So it's just that only you just study the lecture material that has been taught in the class and the live sessions. So I think that will be enough for these exams. Like it will be similar type of the assignments that you are getting.
Okay, ma'am.
Okay.